All right. Hello, everyone. So we are back a little bit earlier than yesterday. Hopefully we will have some more stuff to do. I hope the audio is also sorted out and the music is not too loud or anything. I might turn it down a little bit more. So I still see a bar here over the chat. Oh, because I probably moved it. That was something I wanted to adjust. Let me do that. Huh. This is interesting. Oh, that's what it was. There we go. There we go. Perfect. Now the Twitch chat is also gone. Yeah, so the stream will essentially be some more shaking out of the streaming setup. We will try to figure out a few more things. Maybe catch up on what was going on. Yeah, to maybe move things around. Anyways, I hope we have 8 people there. That's great. Okay. So, as you might remember, I was streaming the last time probably around a year ago. We were doing electronics assembly and production, and we were doing quite a lot of different projects regarding products that we do here at 1 Bit Squared. Volume is fine. That's great. That's good to see. Yeah, and I basically got involved in the Icebreaker FPGA campaign, and this sucked out all my time. And this is pretty much the same case still, but I think it is important to do some streaming at least to keep you guys up to date about the different projects that we are working on, and maybe do some hardware hacking together, because I think there is not enough hardware hacking on the video platforms around. As you might see, I moved I stopped streaming on YouTube. This stream is only on Twitch, and I will keep this way. So I will be only streaming videos on Twitch because they are a little more liberal with content matching. So the video on demand stuff that is being recorded on Twitch will get some of the background music blanked out, but I was watching more streamers on Twitch, especially in the group of live coding, and I was thinking that having the background music is very nice. It gives a little bit more of a nice atmosphere for the streams. So that was more important to me than streaming on YouTube. Still, in OBS, I'm recording the streams onto my local computer without the music track. And if you are watching this afterwards, you probably will. It's possible you will see it on some other platform without the music background. If I upload it, the idea would be to upload it probably to a Diode Zone or another federated video service, as well as probably on YouTube maybe, but I'm not sure I want to do that. The idea is that a lot of the streamers that I've watched, they basically stream on Twitch and then cut down the videos into something shorter if there's anything really interesting, and then post it on YouTube as a semi-edited video. So this would be the model in the future, if I come around and have the time to actually edit the streams. So that would be that. If this stream works well, I will try to do it more regularly and then come up with some schedule so that we can have those streams on a more regular basis. My thought was to keep those streams to around 2 hours, not much longer than that, because I also have other things to do. And streams are great, but they take, well, I'm productive here too, but it's in a different format. So to keep a schedule so that we can get on with different projects where people are bugging me about, then yeah, this would be the solution there. Yeah, so hopefully not 7-hour streams, so that people are not complaining afterwards that they have to watch too long of a video on demand recording. Yeah, so let's see. Robin, welcome. First time watching stream content. Thank you. I'm glad you like like my Twitter. Yeah, I should actually, now that I think about this, I should post this also on Mastodon, because I didn't. I just posted it here on Twitter that the stream is going on. So let me just do that really quick. Be right back. Then that should be fairly quick. I just need to get my... There we go. There we go, one, and then the link to the Twitch. And then the picture. Let's attach the picture. Huh. And my computer decided to hang. Okay, whatever. All right, here I'm back. So, yeah. If you guys have any questions, oh yeah, there we go. Now it stopped. I just saw it with the corner of my eye. Yeah, I don't know what is going on with that machine there. I'm not streaming from the other computer, so it shouldn't have any problems. But no, you click on something and then it hangs. So great. All right. So what else? So besides the icebreaker campaign that was going on since last year, we also brought. I went to a bunch of not campaigns, a bunch of conferences here in the US as well as in Europe, so CCC in Europe, and then multiple campaigns here in the US, and we made a lot of new contacts with a lot of awesome people. And the next project that we will be the biggest one we will be working on is the Glasgow. This is this guy here. It's White Quark's project, and this device is an interesting FPGA-based protocol. I would say generator and digester. We call it Digital Interface Explorer. And hi, Timon. And this thing is pretty powerful. And the most amazing thing about this, it is mostly enabled by the open source tools. So if you think about a device to speak an arbitrary protocol, digital protocol, like FTDI chip, for example. And they are either have a built-in hardware to speak a certain protocol, like UART or SPI, or you have a microcontroller that speaks also certain protocols implemented in hardware. And anything beyond that is not a specific protocol implemented already in hardware, you either have to bit bang it or build your own hardware around it. So the Glasgow does it differently. It has still a USB to parallel bus converter, an FX2 chip. This is exactly the same part as on the basic logic analyzers, the old Salia Logics, or the clones from China, or the BitMagic that we released last year. That didn't have a campaign, but it is finally a product in our store. It is a dedicated logic analyzer for SIGROC, this amazing logic analysis framework. And BitMagic uses the FX2 to directly read out 8 channels of data. And the same chip is here on Glasgow. And in front of it is an FPGA. It's an ICE48 HX8K, which is supported by the open source framework. And the rest is basically software. It's a Python framework that generates the necessary hardware for whatever protocol you need to speak. And you can create your own protocol hardware that will then on the fly be generated, put into the FPGA, and you can talk this protocol. So during the streams, you will probably see a bunch of this new hardware because I am gearing up to launch the crowd supply campaign for it. And there is still a bunch of work necessary to be done. For example, I made these prototypes here, and I did it in a rush right before I was leaving to Europe. And 4 of them so I made 6, out of which 1 was actually fully working. The rest had some issues. Another one, Kate Tempkin, repaired for herself and took, and will be playing with it. So that's pretty cool. And the remaining 4 have some issues, and Kate was wonderful enough to write down what the issues are with them. So I think 2 of them seem like a fairly easy fix. 2 others have some shorts that I'm really curious if I will be able to fix easily or not. So we probably will try to look into that today. Yeah. Oh, Sedacious. Welcome to the stream. I'm glad you're excited for the Glasgow. I'm excited for it too. Can't wait for it to for the campaign to launch. But as I said, there's still a few things to do besides the hardware and sending it to a few more people. I also have to write a lot more description for the project, make a video, make photos, and especially figure out what the main demos should be to put it in the campaign, how to describe it. It's like you just realize I needed 5 minutes of talking to roughly give you an idea what it does. And I still having a lot of trouble to find a good elevator pitch for it that doesn't require comparison to other hardware that people might not know, or because there's not really many tools like this. Logic analyzer, people know what it is. Oscilloscope, people know what it is. Maybe network analyzer, people will know what it is. But there's not really a good category name for this kind of tools. That is an arbitrary protocol in-out device over USB. So it is an but also saying that it is just USB to N is not good enough, because it's not bit banked. So it actually, you generate the hardware to speak a certain protocol. So it's more like synthetic protocol, USB to synthetic protocol or something. Anyways, so I'm putting it out there. Maybe someone of you guys will come up with a great short description of such a device, as well as maybe help me hone the good elevator pitch for describing Glasgow in general. Okay. I'm glad you like it, Robin. Good. So let's see. We have, thanks to, this is also new since our previous streams. Let's see. Yeah, we have a desktop camera, thanks to Chris Gamel. He he told me at SuperCon, so by the way, I got a bunch of cameras, he said, and I want to get rid of them. And I was like, what is it? How much? I need more cameras. So he was great enough to provide me with some really nice camera hardware to use for streams and video. I think we need better lighting on the desk still. I think I have to install a bar of light above the desk here that I wanted to install for a while. But yeah, anyways, you can now see what the Glasgow looks like. So for a little bit more description here, the hardware itself is, you have USB, you have FX2, and you have the FPGA here. Then you have two separate banks with 8 I/O each. A sync interface, so you can sync multiple Glasgows together. And then you have level shifters for all the 8 channels that this thing has. Then both banks have their dedicated voltage regulator that can be set for a voltage between 1.8 and 5 volts. So each bank can have its own I/O voltage as well as supply some power. Then there is also one ADC per side, so that you can sense what the target voltage is. So for example, to follow the target voltage. And then you also have these I/O expanders that can set pull-ups or pull-downs or nothing for each one of the I/O pins. So you can do a lot of things without adding additional hardware to it. Yeah, and then you have some here, some user LEDs to put in your applets. That's how the FPGA part is called. I think it's called applet. Synthetic Logic Fiddler. Yeah, that's not a bad name. Thank you, Timon. Okay, so let's see what issues we have here. So one of the cards says fails QFN bridges and a dry joint. So we would need to, I think this is the FX2 that needs a little bit love. I even managed to get Glasgow, the software framework, running before. So that was a somewhat funny story. If you look in Discord, in the streaming channel, I was trying to debug that just before the stream. So so basically what happened is I have terrible luck, and every time not every time. So last time I was trying, before I left for Europe, to test these and installed Glasgow, and somehow it didn't work. And then it turned out I had some lingering issue on both of my laptops, so I had to wipe everything. So all the Python stuff and all the compiled stuff, and then eventually it worked. But I only figured that out after I was already in Europe and had some time to... Sylvain helped a lot by saying, it's like, well, it works on my computer, so figure it out. Yeah, so today I wanted to get it running on the second laptop that I have here for streaming, and and it didn't work. But it turns out there was offending patch last night, like 13 hours ago, that went into nmeigen, which is the HDL framework that synthesizes the designs for the FPGA. And I had to check that out, roll it back one version, and then it worked. But the error message didn't tell me anything because I don't understand the framework very well yet. Meek was very helpful there and said, so by the way, it is a bug and it's known, and the newest version of nmeigen has an issue. So I rolled it back and it's everything fine. So at least if we manage to fix any of the hardware, we will be able to test it. And I don't know what happened. Wow, that was weird. I wanted to change my displays and... All right. So that's the microscope. So let's see. What do we have else? Wow. There we go. So let's see. Level shifter 180 reversed. So yeah, one of the boards has the stuff reversed. So Sedacious, what are you saying? That's a good question, Sedacious. So so anywhere when you, it's basic, that's a very good question. I'm trying to find a good way of describing it. Is it so the question is, it's a protocol-focused hardware platform? Yes and no. It is a software framework. So the point is that the hardware is completely abstracted in software. So you want to move all the complexity of speaking a protocol and making a hardware that can speak that protocol from making the hardware into writing the software for it. So the hardware is very flexible, and because of that, you don't need to make a special hardware front end for whatever protocol you want to speak. You just take a Glasgow, hook it up to whatever you want to talk to, and then you just write software, which is much faster turnaround than ordering PCBs or designing some hardware that can speak that protocol or get a new microcontroller or whatnot. So you move the hardware problem from the hardware domain into a software domain. That's I think the best description of what Glasgow does. It's converting a hardware problem into a software problem. So I hope that explains it too a little bit. So yeah. Okay. Let's see. There we go. This is one of these guys is turned around. Yeah, there we go. So I managed to mount this guy upside down. So let's get the... I'm really curious how loud this heat gun will be on stream. And the first thing is to just Yeah, this. Yeah, Robin says that it sounds too good to be true. Well, yeah, that's the point. That's why so many people are excited about this. There's a lot of people even building their own Glasgows right now because they just want to have access to it. So despite it being quite a lot of effort, there's a lot of parts, and the design is fairly, yeah, there's BGAs on it and a lot of fine parts, so people still build it themselves because it is a really cool piece of hardware. And to have access, basically you can't use the software without the hardware. So you need to have the hardware first. So that's the part, and then the rest is software. So yeah, we need. There we go. The sonic screwdriver for electronics. Timon, that's a great reference. I like that. It is pretty much it, because the sonic screwdriver can do pretty much anything. Yeah, this is good. I like that. I just wish that it was just doing the right. So the sonic screwdriver is a little bit more than that. It is more of do the thing that I want you to do, and just do it, and you don't have to really like tell it very much. So Doctor Who is very quick at adjusting it to do the right thing. Yeah, but it's not a bad reference. I like that. Oh, Azidon, welcome. Happy New Year to you too. Yeah, long time no see. But I'm trying to get back on my streaming horse again, so that's my best effort here. Yeah. George will complain probably when he sees the stream. It's like, why are you not using the coffee cup warmer? Yeah, that's a good question. I should actually pull it out. The main reason is that it adds a lot of height to and it's a little bit fiddly too. I need a flat version of it. I need to figure something out. There we go. Finally. Just took a while. Scoot. Oh, great. I will have to resolder that guy right next to it. Come on. Nudge. There we go. So that's good. Now let's fix this guy that I just screwed up right next to it. Yeah, so the biggest problem with this revision of the PCBs, which we will have to fix, is that there's no webbing between the legs of those SOT666 parts. And that I get shorts very easily between them. So there are two things that I have to do is order it from a PCB manufacturer that can do finer webbing, which should be doable. And then second, I should fix the footprint, because the footprint is the default one from KiCad in here. It's fine for one-off or whatever, but for bigger manufacturing, I figured out a better footprint that I'm using on the Blackmagic probe. Maybe I will show you really quick. So this footprint can see how that looks. Let me find a Blackmagic probe. There we go. You see the difference. So first of all, you have the webbing between the pins. So here is the webbing. Second of all, this middle pad is longer so that it adjusts the position better. And the inner ones are shorter. So basically this one is longer but not as wide, and these are wider and shorter. This results in the fact that you have more space between the pads, so the webbing can be created. Yeah, so that's the, I want to replace them on the at least on the Gerber files that go into the production with us. So 1-bit squared. So yeah, the sonic screwdriver is a little bit more automatic. Yeah, Timon. So I think Doctor Who actually does. He's so intelligent that he can, or she. Now it's her now, right? So that she can automatically modify the programming with her mind. I think that's how it works. That's why it is so much faster. So we not only need a more intelligent tool that has some AI in it, I guess, we also need a brain-machine interface. So yeah, there you go. That's brain-machine interface AI protocol tool that does everything. Or yeah, you are just brain controlling inanimate objects or technology. Damn. What's the pitch of those? Yeah, they are just on the verge. So Timon is asking about the pitch of the pads. It is, the default footprint is just fine enough that PCBWay and LCS or JLC PCB, I think it's beyond their standard capabilities, definitely for black solder mask. So that's an interesting thing. Black solder mask is coarser than other colors. So yeah. And EEG to the Glasgow, yeah, I'm sure that would work. Oh, maybe not the full interface one. Aren't these analog interfaces? Don't you need like multiple analog channels for EEG? How many? I'm not starting to look it up yet. So, so Ed, please enlighten us. But yeah, I'm pretty sure it is doable. It's we could just connect any ADC to this and then connect it further, and have multiple channels of them too. So that's also the beauty of this system. If you, I'm not sure it is supported at the moment, but hear me out. You could, for example, say, please give me 7 UARTs, and it will just instantiate those and put it on different pins of the interface. So, or you want 16 one-wire interfaces. Sure, no problem. And it's supported in hardware, and the hardware that is parsing those protocols is just right there in the FPGA, which is very nice. So I'm really looking forward to this kind of stuff where you can just automate things. Okay, don't stop. So what is else? So A3 level shifter 180. A3, oh, this is the A3 pin. Yeah, so that's, let's see if that was correct. I should open KiCad and check. And then B2 and B3 short on RN3. There we go, and I see it. Wonderful. Should probably use my soldering iron for that. Let me have a short drink. All right, so let's... Oh, I don't have power. Don't have power in my soldering iron. What the hell? Oh, there we go. That's better. Okay, now I can actually switch this guy off for a little bit. You see the RN? You see the short? I see the short. There we go. Should probably reflow the other. Man, I wish the heat gun was quieter. The pump in there is pretty loud. Come on. There we go. Yeah, these guys want some love here too. I'm sure this is reflown, but just fix this while I'm already here. There we go. Okay, so let's see. So that's in theory both things that are failed on this board, according to Kate. So let's see. Let me switch over. Still need the desktop. PC desktop is F3. So let's switch over to let's see if that works. There we go. Perfect. Well, it's overlaid. Still should be good enough. So yeah. On this view, we don't have the desktop. So I think, yeah, this is something I have to do now for the streams. I'm missing a few. So let me add. Not screen capture, it is video source, video capture device, and I want the desktop. Okay, and make this much smaller. There we go. And we will move me down here. There we go. And this guy goes on the top here. Can make it smaller. There we go. That should do the job. Bam. I still need to adjust the head here. All right, so yeah, let's do this. So I power it on. There we go. You should be able to see it. Now let's do Glasgow vrun self-test. Let's see if that works. So it is now synthesizing the bit stream, loading it, and should run through the test in a second. Still synthesizing, I think. Should be some progress on the synthesis. There we go. Self-test failed. So which pin is that? Short, B2 and B3. So we still have a short on B2 and B3. Good. Well, not good, but which way? There we go. And I should probably make a focus on this. So I didn't refocus the camera. Okay. B2 and B3. B2 and B3. Let's see, let me get a multimeter. Zero. 0, 1, 2, 3. So this, yes. So this is shorted. Zero, 1. These guys? What? What's going on here? Let's open KiCad on this. I'm confused. So where does this go? So 0, 1, 2, and 3. Oh, wait. That was the ground that I was comparing. Okay. You don't have a short here. Not on this side. Does it have a short on the other side? But for that, I think it says on RN3, B2 and B3. Well, I found RN3. RN3 would be this guy. Ah, there we go. So there's a second short here. Haha. Okay. No problem. Just blind. There we go. Come on. I have extraordinarily shaky hands today. For some reason. And making a mess. Great. Making more shorts than fixing. But maybe I just should drag it out. Almost there. Almost there. There we go. Okay, let's see. Welcome, Donker5. Welcome to the stream. So, let's do this again. Switch over. And number 3 should be the screen. Let's see, there we go. Let's do a refocus again. There we go. Connect. And rerun the self-test. Should do more caching. I think when you replug, it doesn't keep the cache of the bit streams, but I'm not sure. I think it should, because the hardware doesn't change. And then rerunning the... It's not that long. The biggest problem is that I'm running it on a computer that is fairly old. Oh my god! It's much worse, is it? Yeah. Short B3, B4, B5. And then fail short B3, B4, B5, B6. Wow. Okay. Let's fast forward to the next track here. Yeah, I still have to go through the playlist and filter it out. I didn't come around to it. It's just the new retrowave label playlist at the moment. Yeah, I think there's just more shorts here. Yeah, the alternative is it might be also further down the road from here. Okay, let's see. What? In the wrong window. Okay, B4 and 5. So we are moving. We are moving. Okay, let me measure it. So it's 0, 1, 2, 2, 3, 3, 4. What did it say? 4 and 5? Four and 5. 8, no, 7, 6, 5 and 4. So not on this side. Should be, unless it is on the other side here. Okay. Let's open this after all. Revision Glasgow. Where are we? Hardware. Okay. Let's open this up. Oh, come on. Open it on this desktop. Okay. All right. QB6776543210. Okay. It's also always possible that it is there's a short on right. So there is possibility that there are shorts all along here. 4 and 5. Then 5. Yeah, it is unlikely that it is shorted to here. And it's shorted to here. So, okay, so it is actually in order here. 4 and 5. So there might be something going on here. So this is the last set here. So let me just redo this. Nope, nope, nope. Nope, nope. Okay, let's rerun this. What's going on here? All right, let's rerun this. B4 and 5. It might be also some link, very weak connection between those two. Not sure how sensitive it is. Oh, Bolt Engineer, thank you for hosting me. That's very nice of you. What happened? Why is the desktop just gray? Let me see. Huh. Oh, it didn't switch over. Yeah, that's stupid. What I need is inspect AR. I do have inspect AR. I'm not sure we have this for Glasgow, but we have it for the icebreaker. So if you don't know, it's a augmented reality tool that can show you all the traces. Yeah, it's like I told I made an account on Inspect AR, and they asked for like a review and some like a survey. I did fill out the survey, and the main thing I had to tell them is you need to have upgrade modules for microscopes, because that's the most useful thing for Inspect AR, to actually see it through the eyes of the microscope. Just using it separately with just on the phone is only half useful to me. Personally, I think if this was in the microscope built in, that would be super useful. Okay, so I don't understand. It's still complaining about B3 and 4. Let's go on. Yeah. 2 and 3. So 2 and 3 was a problem, now 3 and 4. Yeah, so there's also beyond the self-test. The self-test has multiple functions. It also can test the pull-ups and other things. So this is pretty nice. Yeah, I don't know what I'm doing wrong here. Let me just fix this guy. It just looks wrong here. Because it's crooked. Let me just reflow both of these guys, because this is 3 and 4. This should be 3 and 4. Or rather, yeah, 3 and 4. Correct. But I don't see it being an issue with the multimeter, so that's weird. Curious where that issue might be. Yeah, this is how rework works. Okay, let's get this guy. So Ed, I think, yeah, that's a good point. That if you just have the camera sees exactly what you see, but I think it might be a combination of what you see and a more of a global view. So the microscope knows better where it is. But yeah, I don't know what the technical solution should be. All I was saying is like, make it happen. That's the easiest technical solution. Just be the manager that says, it's like, I don't care how you do it, just do it. And I think most customers are like that too. Where it can't be that difficult, just do it this way. Why is it not doing it the right way? There we go. So that's better. That's good. That's fixed. The next thing would be basically to clean it, I guess, or measure the resistance between the pins, because it might just be a weak resistor. Okay, let's test it one more time. 3. So Donkers, the Glasgows are currently in like prototype stage, and we are setting up. Oh, there we go, it passed. Perfect, so that was it. So I guess one of the level shifters was being wonky. Okay, cool, sorted. So to answer Donker's question, Donker is asking if the Glasgows are in the store. So these are still prototypes. We're gearing up for a crowd supply campaign. If you look at the bottom of the stream, there is a Bitly link. This is the crowd supply campaign page, and I'm hoping to launch the campaign very soon. And this campaign I'm planning to implement in a way where we will get the hardware much faster than previous times. So as soon as we launch the campaign, like when the campaign ends, I want the hardware to be sent out to people much faster than in my previous campaigns. So so we will see how that works out, but I have some ideas how to do it. But yeah, several people already built Glasgows. It is a possible thing to do, but it is also not the simplest thing to do. As you see, I'm running into manual manufacturing issues myself, as you see. But the tests are very useful. Yeah, let me show you also the run self-test. What was it? Minus help. Yeah, so there is more test modes. More test modes. So self-test is we can do pins pull. I'm really hoping for bitstream caching. That will be wonderful. Okay, cannot set IO port AB pull resistors to low high. Curious why. I assume this is the I2C interface issue. Let's see, pins loop, pins X, the direct shorts and opens on traces between FPGA and IO connector. I'm glad, Dunkers. Thank you. Yeah, there is a subscription. We will send out emails to everyone as soon as it launches. So that would be an option. But yeah, as I said, you could build it. You wouldn't be the first one. There's several people that did that. Lib USB transfer error? Ooh. I assume this is because I have so much USB stuff running on here. I shouldn't be doing this kind of testing on the streaming machine. That's essentially the truth. Because I have what? I have audio USB, I have 2 HDMI streams over USB. Yeah, lib-USB transfer. I don't like that. So it fails half through. Yeah. Not pins, but check. Let's test the voltage, because that's also I2C. Ah, yeah, there we go. Oh, because I should loop them. Right. Okay, let me get the jumpers. I was using jumper wires right very recently. Oh yeah, I know what I was using them for. For another project. Can I use something different than this? I have one here and one here. There we go. Perfect. So let's jumper the voltage and sense wires. Voltage and sense wires. Still, this lib-USB transfer, that is not pretty. Yes, it's definable in software. You can also define if it should follow by itself or it should... Okay. So yeah, we have some issues here. Why is the USB failing? I don't understand. I should probably clean up the soldering on the FX2 chip here. Well, it doesn't look that bad. It's not pretty either. Jesus. Oh my goodness, what's going on here? This is when you rush assembly. You don't paste solder paste properly, and things become very wonky very quickly. I only hope that the BGA is fine. Oh man. I really don't want to rework the BGA if I can avoid it. Yeah. Doesn't look too bad here. Oh. Ooh. You look dry. Very dry. Okay, let's fix that. So these are the pull-up resistors. remember correctly. So basically, pull up or pull down. So essentially, you have these GPIO expanders that are on I2C, and you can set it high impedance, so then this resistor doesn't do anything. Or you set it high, then this becomes a pull up, or you set it low, and then this becomes a pull down, which is very nice. Very nice solution. I think so. Timon is asking if it can be, the voltage can be set in arbitrary steps. I think it's arbitrary because it's a DAC that is setting the voltage for the voltage regulator. So I think you can set it to anything you want. Just this test is doing 1.8, 2.7, 3.3, and 5.0 volts. So yeah. But I don't think this is specifically fixed to that. So Donkers, that's a hard question to ask. It really depends on where you get the parts. But I think it is, if you build just one-off, a few pieces, it's $60 or $80 in parts. Plus stencil, I guess, and PCBs. Let's fix those pull-ups. I'm curious why it is the USB is crashing, lip USB transfer error. I really think this is related to me streaming at the same time. So I should probably try it also on my different laptop just to make sure that this is not, that this is a software issue on my laptop and not something else. Are we there? Oh yeah, of course. Should be more careful with how I put things under the microscope, because otherwise you guys don't see anything. There we go. Clean, clean, clean. It says it cannot set anything. So let's check if the I2C interface there's any shorts or anything. I think there's a guy, the I2C is here on those connectors. Why is it not? Or is it just aux? I think this is just aux. VIO. SDA, SDB. Oh, it's going all the way up here. Okay, still learning the topology of this board. So the I2C is connected to the FX2 chip. Oh yeah, sorry, I will show you. FX2 chip as well as the FPGA. Yeah, I have the feeling there's some dry. Yeah, it very much looks like a dry solder joint in here. Yep. Okay. So let's try to look in there. No, it's actually pretty good. Looks fine. From the top it looked weird. This looks fine. And we have the diode. So let me just measure it. Let's see if we have shorts or opens. Let's do that. Oh, what it says? Yeah, I do. I know what it says. A hint might be that the character on the back is called Hannah. So so the resistance should be 4.3 kilo ohm. Is that correct? Just give me resistor 1. Should be a 2.2 kilo. Yeah, so it should be 4.4 kilo ohm between the I2C lines. So that's good. Then they should be pulled to 3.3 volts. And so the resistance to ground should be quite high. Yeah, it's like 2 mega ohms. So that's good. You can see here. Haha, I can show you the desk. Again, so resistance between the two is 4.36. That's good. And then to ground, 2.2 mega ohms. Oh, 2.2 mega ohms. That's fine. And 3.3 volts. Where do I have a test bed for 3.3? Tuk. Oh, it's here. It's 3.3. 3.3. And it's 2.15. That's fine in kilos. Yes. It's a bit weird to see. Well, and 2.2. Okay. So that should be fine. Now the question is, what's wrong? What is wrong? Oh, look, fine. Is there any other path that the output of the Okay, so let me test this really quick on my other laptop, just to make sure. I'm going to take the USB. That this is not just a software issue related to the fact that USB is so slammed over there. Pins pull, pins pull, pins pull. Okay. So essentially the next upgrade for my streaming setup should be to have a not found. Okay, so that doesn't work. Ow! So they are short somewhere on the voltage regulators. They're getting very, very warm. So my assumption is I still have short somewhere here on the level shifters. Oh man, 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 man. Yeah, let's see. Let's see that the output. So yeah, debugging. But at least on the other laptop, it switched on power. VFB. I want my music back. There we go. CLSDA. I don't remember. Okay, give me the schematic. So this is the voltage regulators. How does this work? I/O banks. There we go. And then we need buffer B. And then we have, what do we have here? So TPS, so this is the DAC that is setting the voltage, the feedback voltage, or biasing it. And this is the voltage regulator. This has the enable is the green LED. So the green LED is just the enable. Okay. And the VIO is here. So VIO, and this is the U14. U14 is this. This fella. VFB. Oh, yeah. Doesn't VIO is behind the. So I can, out is pin 5. So this is out. What do I have set here on the back? Do I have the one resistor? Yeah. And this is the R48. R48. Okay, so what I should do is at least measure the resistance between ground and this. So let's see. We have a short. There's ground. Ground is in the middle there. Oh yeah, very much so. Very much so. But how much is it? 1 volt. So this is the 68. It's 0.68. Yeah. Okay. So it could be also on the back side, on the other side of the resistor. So VIOB. Okay. So this is this stuff here. Where does this go? It goes all the way here. So it could be okay, so it goes all the way here. So it can be all shorted to the middle pads here. It's totally possible. So I am afraid of these guys being a problem. Because there is no other ground close by. Because these are connected to ground internally in the package. So what is it? So this package here is an array of diodes. So this is basically ESD protection diodes for all these pins in this package. The problem is we were already discussing to remove these middle pads because we already had a few shorts on those. So in the next revision we will also remove those in the footprint because they are not really necessary and we are not really using them, as you see. Yeah. So how does this work? So VOB, so this is the third pin. Oh man, that will be fun to remove because it is so close to the plastic. Man, I don't like it at all. Give me some ground. Huh. Come on. Wait. So this is the output. Yeah, that's what we said, correct? This should be shorted to ground. Yeah, it is. Okay. Sure. Am I not able to just connect to this properly? That's the problem. Yeah, anywhere else where we could have a short. Yeah, I guess. I'm really not looking forward to this. VIOB to 3.3 volts. VIOB to ground. This guy 3IB, this goes through that resistor there. Yeah, well, I guess we have to remove it. So this is the top pin. Let's make sure we get this. Top pin goes to, yep, so this is connected. And then this, yeah, it's connected to ground like no one's business. What about this one? Is the top one also a problem? Oh yeah, both, great, okay. You guys are coming off. There we go. These guys are a problem. I'm curious if this will confirm my suspicion or not. This time I will actually use the preheater because I don't really want to burn the crap out of those connectors. At least, even if I don't remove those pads, I should at least remove the paste from them. And I should add some protection here. Okay, let's see. Where do I have my preheater pad? Ugh. I don't know where I put it. Is it in here? Oh, there we go. I see it. Oop, not the right connector. Hold the light off. There we go. I need to clean up this wire mess in here. Would be a good idea. All right. So this is the heat pad that everyone is raving about so much. Okay. Okay, so we put this like that, and then I need some Kapton tape. Okay. I need scissors. Oh, come on. I'm really curious because yesterday Bob, K-Bob, was like, oh, I missed the stream, even though I stream only for half an hour. I'm really curious what he will say this time, because I think he's missing it too this time. And he will be like, oh, I was out of the house or something. I just thought that was very, very nice of him to mention that. But I didn't hear from him yet today, so there we go. Okay, let's switch this on. Let's see if the flare is charged at all. You can see actually the temperature. There we go. Yeah, I should have foil of some kind to protect the connector too. Aluminium foil. Yeah. Okay, let me see if I can. This will be janky as hell. Let's see. There we go. Let me zoom in. There. How does it look? There we go. You should actually be closer because I have the magnification lens. I don't have enough hands. Oh man. Okay. Needs to be higher. There we go. Anyways, it is warming up. 50C. Oh no, Bob, you didn't miss all of it. There's still 20 minutes. Yeah. I will still be here for 20 minutes. So yeah, you did it. You made it. You made it to the stream this time. Congratulations. Okay, let's see how much damage we will make. Still would like to have some foil. I used to have some aluminium foil here for situations like that, but I don't know what I did with it. I think I threw it all away. But I'm now too lazy to run and recover, so I guess it is what it is. Oh, I could use this cardboard. What about that? Yeah, let's do this. It's still sweating, the connector, despite the cardboard. Should zoom out a little bit, huh? Easier to see. Ah, it's hot. It's hot on my fingers. It's melting. Yeah, there we go. See the amount of solder that came out? Okay, let's see if that helped. Otherwise we will just pull it off. Where was it? We have like a test bed for this? No, we don't. Output, output, output. This guy to ground. Yep. And This guy. Ha! And it's gone. And the short is gone. Yes, as expected. You damn chips. So it is related to the ESD protection diodes. Great. Well, at least we have a fix. I just need to squish it down and squeeze out the excess solder from under the part. So no matter how you look at it, it's at the end my own problem and my own making that I didn't do solder pasting properly. So yeah. Ay, ay, ay. Okay, so cardboard again. Hopefully that helps at least a little bit to protect the connector. It still is sweaty and weird afterwards, but what do you do? Should pick it up properly. There we go. Oh, you've been lurking for 40 minutes, Bob. That's nice. I'm surprised that you didn't say anything. So you usually have good comments. Ow. Still burning my fingers. That's what I'm paying for, my sins, I guess. It's the donation to the electronics gods. It's the burned fingers. Sacrifice. Okay. Let's now there we go. Let's test it. Am I doing the right thing? Wait. This is the top one to the ground. It seems to be fixed. Okay. All right. Let's see. This fixed the issue. Ow, hot. Toasty. Let's get the USB cable again. Let's adjust this again. Zoom out. There we go. Let's try the pull-ups first. Haha! Pull-ups work. Let's test the voltage. This will fail because we don't have... Okay. Let's reset it. this is signal data, chunk. Let's jumper it, jumper, jumper, jumper. Yeah, I'm pretty sure reworking more boards will just get easier over time because I will learn what the pain points are. But still, we need to adjust this in the design. So I'm sure this will be good content for the stream. Donkers, yes. Oh, yay! It worked! It passed! Okay, so that's working. That's nice. Okay, so we have... so what other tests? Let me switch this off. Because we are getting to the end anyways. So I will not be reworking more boards today. But let's see. Maybe we can see what other modes are. I think there is also one where I have to jumper all the pins together, where it's a reflection. So loopback, detect faults in USB FIFO traces. All ports, so voltage, all ports vSense and VIO pins must be connected. That's what I did. Pins loop, detect faults anywhere from I/O circuits. Pins A0 to 7 must be connected to B7 to B0. Yeah, I need like a ribbon cable to connect, to do the harnesses. Then pins pull, we already tested that. Pins ext, we can do pins ext. Let's do that. So that worked. And what else? Pins internal. I think that's part of the normal test. Then the loop. So the loop is the only one that we need to connect them together. So so I think we have it mostly working. I still need to do the loop tests, but for that I need more jumper cables. So that might be something to make. So I should probably make more jumper cables, or find them, because I guess I have some jumper cables somewhere. And then we will know better what the, and I think we have another working board. It's like, that's, I think, it. It's a fully working board. That's nice. So we did manage to fix one board in the, well, it's not 2 hours, because maybe an hour I was actually working on it full time. Anyway, so let me look at the chat really quick. Yeah, burnt chicken. Yes, I know. It's my hand, but I survived, I think. Degree. Applied several for hardware, couldn't get it, ended up. Oh, so you applied. So first of all, Gombak, is that the right pronunciation of your name? So yeah, welcome to this stream. So you graduated with electrical engineering and applied for several hardware positions, I assume, and you couldn't get it and ended up in software. So yeah, I've seen a lot of people that are electrical engineers end up in software, and people like me, for example, who have like a computer science degree end up in hardware. So it can go both ways. And at the end, I think it's both types of jobs is mostly us knowing how to solve problems. So it is applicable, which is nice. Yeah, and welcome to this stream. I hope you like it. I'm trying to essentially do a lot of electrical engineering here, because we have plenty of software things on Twitch, but not very much hardware. So yeah, that's my attempt to add to that conversation here. Thank you, Mike. So Mike is just saying in the Discord chat, the loop feature got a fix right in the last update, which is funny because me updating right before the stream into the newest version ended up being a problem. so yeah, funny, not funny, but yeah, it's okay. So let's see. Let me switch over to, I think, my face. There we go. So yeah, we are getting close to the end for today. So Donkers figured out the Japanese part. So yeah, I don't think this is actually a secret. So above it, it says, it's like, I can do anything, I think. And in brackets is actually the name of the character, Hana. So that's what is in the brackets in kanji. But yeah, I had to look it up myself and use Google Translate and stuff. So yeah, so anyways, it was really wonderful to have you all back here and watching the stream. And I will be back. I don't have a schedule yet, but I think it will be something. I will come up with some schedule that will be regular. I will at least try to do that, because this way everyone can like plan around this a little bit more. And I know that a lot of streamers do that and have a schedule, but it might become very difficult, especially when the campaign is going on, to keep a schedule, especially when there are very important things to do. But yeah, if I keep it to shorter streams, around 2 hours, then it shouldn't be too big of a problem to actually make a schedule and keep to it. I'm not announcing directly when I will go back live again, but maybe tomorrow, who knows, if everything goes well. And then we can work on another board and debug it, because as long as you guys enjoyed that debugging session and fixing of the board, hopefully tomorrow it will go a little bit faster. And I will be able to send some more boards to developers. Also, if you know of good YouTubers that actually would use it for a project at Glasgow, let me know, because these are people that I'm looking for that would be interested to actually use the Glasgows and make a project and talk about, in the scope of what they are working on anyways, if it was useful or not. This is something I'm not looking for people that just do unboxing and then put it in a drawer, because that's a waste of the hardware, in my opinion. Yeah, that would be it. I hope you enjoyed it. I hope you had a good time. I definitely had a good time. And I see you soon. And if you have been, thank you for watching. Bye.